This is my first term. You see him? He's the first term of a geometric sequence. Now, do you guys know what a geometric sequence is, right? So, like, how do you get the next term in a geometric sequence? You multiply it by the common ratio. So, the common ratio could be anything. It could be a 1/2. It could be a 3. Doesn't matter. So, if I were to add a geometric sequence together, it would look something like this. A sub 1 plus... let's change this a sub 1 really quick, make it nicer. Plus a sub 1 times r, because that would be the next number, right? What would be the next number after that? A sub 1 times r squared, right? Because it would be 2 r's. And then what would the next one be after that? A sub 1 times r to the third power, right? So we see the pattern. So I'm going to say plus and go dot, dot, dot. Because we're going to do a really big geometric sequence, and I don't want to write them all out. So what would be the second to last term in this sequence? If there's n terms, right? N terms. So we got n terms. Okay? So that's like saying, like, if there was 10 terms, what would be the last term? Like, what power would the last term be if there was 10 terms? No? Yeah, it would be 9, right? Does that make sense? Yeah. The last power would be 9. But if we don't know that there's 10 terms, so I just say there's n terms, what would be your last term? N minus 1, right? Okay, so that means our second to last term wouldn't be, it would be a sub 1 r to the what? N minus 2. It'd be 2. Okay. Hold on, let me fix that. Oops. Let me fix that. Not 1, but 2. Okay. So after that, we would add the last term, which would be a sub 1 r raised to the n what? Minus 1. Okay. Why is it like that? Okay, here. Check it out. Let's pretend it was 10 terms again. Okay. This would be 1. That would be the first term. And notice how there's no r. Okay. 1, 2, 3. This is the third term, but you see the exponent? 4. This is the fourth term, but you see the exponent? Yeah. So I go 5, 6, 7, 8, 9, 10. If this was 10 right here, that would be a 9, right? It'd be 1 less than the total number of terms. And I'm saying there's n terms. So this would be your last term. Now, I said 10 just to kind of help you like concretely see it. But we're saying we don't know the number of terms. That's why I did a dot, dot, dot right here. Okay? All right, so this equals the sum of n terms of a geometric sequence. Okay, so I'm going to write the same thing, but I'm going to multiply everything by r. So we have r times a sub 1. Okay, and I'm just multiplying by r. And I'm going to keep the r out so we can see it. And then I'm going to multiply this by r. I'm going to multiply the next term by r. And I'm going to multiply the next term by r. And then we have our dot, dot, dot. And now I'm going to multiply this term by r. So it'll be r a sub 1 r to the n minus 2. Not 1, but 2. Okay, and then we have r times a sub 1. Or, I'm sorry, times a sub 1 times r raised to the n minus 1. You guys still with me? Okay. All right. So this side is going to have s of n times r. So it's the same equation, but I'm multiplying it by r. Okay, now I want to subtract these two equations. What do we get when we subtract these two equations? What would this look like? S of n minus r sub r times s of n. So we're just going to write that out. Okay? And then what about the other side? I want to subtract all of this by all this. So it'd be the top one minus the bottom one. It looks gross right away, right? But look at that. You see this term and this term? Aren't those the same?
What?
Yeah, those are the same. So this is going to go away.
Oh my gosh, wait.
And then this is going to go away with this, right? Because that's 2 r's right there. You guys see that? And then this one goes away with this one. And then there's one right here that would cancel out this one. And then this one right here would cancel out something right there. And then this guy right here would cancel out that guy. So what's left?
A plus.
A minus.
A minus.
Okay. So we got,
A minus R.
we got to cross all those out. So we got a sub 1 minus r, a sub 1, r raised to the n minus 1. Okay, you guys see what happened so far?
Mm-hmm.
Okay.
Wait, where does from the bottom, the RA1, R3?
Like when we got to this guy right here, this would be a sub 1 r to the 4th, but we didn't write that one. But we know it's inside this dot.
Okay.
And so same with this guy right here. This one right here has an r multiplying the r to the n minus 2. So this is technically just a sub 1 r to the n minus 1. So this guy cancels out with this guy. But this guy cancels out with someone inside this dot. Okay, so over here, next what we're going to do is we're going to get the s alone so we can see our formula. So we're going to take out an s sub n. If I divide this by s sub n and divide this by s sub n, what do we get inside the parentheses? 1 minus r. Now on this side, I'm going to take an a sub 1 out. What do I get when I divide that by a sub 1? 1. What do I get when I divide that by a sub 1? R to the n, right? Because r times r to the n minus 1. Isn't that just r to the n? Because it's r to the 1 times r to the n minus 1. And so you would get r to the 1 plus n minus 1, which would cancel out with the 1s. Yeah? So that we have minus r to the n. And then what will we do to get the s alone? I don't know. You guys like? Is it interesting? No? Like, hey, it's the formula that we memorized. A sub 1 times 1 minus r to the n over 1 minus r. Now, this will find you the sum of any number of terms n of a geometric sequence, okay? And you guys know what r is. R is your common ratio. A sub 1 is your first term, right? Okay, now now it's for a finite number of terms. That means like you can actually count those numbers of terms. There is an infinite sum. Like you can have an infinite number of geometric sequence numbers, and you can actually find the sum of those numbers. And this is really hard to wrap your mind around. It's really hard to understand, but hang with me for just give me like 2 more minutes. Let's see if you guys can get this. Now this only works if r is less than 1 and positive. That means it's not a negative number, and that means we have a fraction. Okay, now if r is less than 1 and it's positive, I want you to think about that for a second. If you had an infinite number of terms, what would this n be? That would be infinity, right? And then on the bottom, I have 1 minus r. Okay, what's going to happen to that? And to think about that, I just want you to think about the number 1/2, because that would satisfy this r right here. The number 1/2. Think about 1/2. If you multiply 1/2 by 1/2, what do you get? 1/4. And if you multiply 1/4 by 1/2, what do you get? 1/8. And multiply by 1/2 again. 1/16. Multiply 1/2 again. So the 1 stays the same on top, but the 32, the denominator is getting bigger and bigger and bigger, right? Now what is happening to that number, that fraction, when you get a gigantic number on the denominator?
You're approaching 0.
You're getting closer and closer to 0. Now in calculus, you learn about limits. If you take that to infinity, meaning you take that number on the bottom and make it infinitely big, that number becomes 0. It converges to 0. And we can't see that convergence. Like, we don't understand that convergence. I mean, we can understand it, but we can't experience it. Isn't that weird to say? You can experience this. Okay, here's a picture of the graph. Do you guys remember having a asymptote like this, and then watching this curve just go like this and get closer and closer to the asymptote? As we go towards infinity, this line just keeps getting closer and closer to asymptote. Now, if we can actually take it to infinity, which we can't because we're finite, we are mere mortals. But if we could, we know that it would become 0. Huh? I know, it's really weird. So, this number right here, if the r is less than 1 but positive, what happens to this number? This number becomes 0. So, he's gone. He's 0. So what is my formula for an infinite series, an infinite geometric series? Yeah, I forgot my a sub 1 at the bottom. I had to multiply by a sub 1. So this is it. Let me clean it up. It's a sub 1 times 1 over 1 minus r. And since it's so simple, we're just going to take this a sub 1 and put them on the top. There's your formula for an infinite geometric series.